quick little lesson on radian measure and arc length and sector area. First things first though, in watching videos I want to remind you, you need to probably use the pause button, use the rewind button. Hey, that's fine, it's what you expected to do. And then also you should have your pen and paper out and you should be working the problems along with me and jotting down anything that helps make this more clear for you. Okay? A little reminder real quick. When we've got angles, you're thinking, what do they measure? The answer is not degrees. Angles measure rotation. Degree is just one of the ways we measure rotation. So that's what that top box says, but everybody's familiar with degrees, so I want to get right into radians. Okay? It says an angle is said to have a measure of 1 radian if it is subtended at the center of a circle by an arc equal in length to the radius. So what does subtended mean? Okay? It means two rays are going to pass through the endpoints of an arc. Then it's subtended. So let me give you an example. I start here at the center. I'm going to just make 2 rays from here. Right? There's one and there's another. And these 2 rays are getting subtended by this arc because the rays pass through the 2 endpoints. Okay? If this arc happens to have the same measure as the radius, imagine 2 pieces of string and this arc has the same length of string as the radius, that is 1 radian. Okay? So that's our definition. Okay? So to think about it in another kind of picture, let me do that one more time. We had a picture in the upper right hand corner, they're showing it, but here we've got some radius of a circle R. Here's our center. I take this radius, pretend it's a piece of string, start it here, run it along the edge of the circle. There's the end of my string. That arc length is the same radius, so that makes a 1 radian measurement. Okay? We use the letter C for radians, but oftentimes we omit it. So if you don't see any symbol, that means we're in radians because we'll always use the symbol for degrees. So just so you know, 60 degrees is a little bit bigger than 1 radian. Okay? And we'll take a look at this again. Think about a circle. Okay? If I have a radius r again, what if my arc length was pi radiuses long? Okay? And, oops, let me try. I guess that's not going to close. Oops, sorry, there we go. Right? So here's the picture that we can talk about. The circumference of a circle is 2 pi radiuses. So every radius around the circle, right? Here's about 1 radius. Okay? Here's about 2. There's about 3, and then just a little bit, right? That would be pi. If I went 2 pi radiuses, I'd go all the way around. So 2 pi radians is 360 degrees, okay? Just like pi radians, right? 3.14 radiuses all the way around gets me half of the circle. Okay? So use that as a unit conversion. So you're used to unit conversions, like 12 feet equal, or 12 inches equals 1 foot, 100 centimeters is a meter. Okay? So we just multiply, if we're in degrees, we multiply by pi radians over 180 degrees. So here's an example, 45 degrees times pi radians over 180 degrees. That's just my unit conversion. And I get 1/4 pi. And we'll typically write that just as pi over 4. No symbol, that means radians. You can do this one on your own, and hopefully you can confirm that this is about 2.21 radians. We also want to be able to convert from radians to degrees. So in this case, I have 5 pi over 6 radians. I'm going to multiply by 180 degrees over pi radians. And so we get pi divided by pi is 1. 6 goes into 180 30 times, so 5 times 30, I get 150 degrees. You need to be able to convert in either direction. Okay. So here's some definitions we need to know. Some of them are old, things like the center of the circle, radius of a circle. Okay, a chord goes from one point on the circle to another point on the circle. Maybe 2 new terms might be the arc, which is part of the circle, a sector, the area that's made like a pie shape, or a segment. If I connect a chord, I can get a segment. Okay? With that, there's two other ideas that go along. Right? Anytime I draw one arc, well, I've got the red arc, but there's also a blue arc, which is much bigger than half the circle. Okay? So this would be the minor arc. The blue one would be the major arc. Okay? If I were to look at a sector, okay, here's the center of the circle, right? So here's a sector, it's less than half, so that's the minor sector. And of course, that also makes a major sector. That's this piece. Okay? Last thing to do is to take 2 points and make a chord. Okay? This little red segment, right? There's our minor segment, and the other half, the big piece, the blue part, all right, there's our major segment, right? So all the blue parts are major pieces. Okay. Let me just get my thin marker back here. A few more. Oops. So a couple formulas for you. The first one is arc length. Okay. And if we label an arc length L, that's the common letter we'll use, and we measure our angle in radians, then this formula will work. So the way we get it is a ratio. Think of the ratio as part to whole, right? The arc length is part of the circle. The whole circumference of a circle would be 2 pi r. So L over 2 pi r equals, and then we look at the angles. A part of the angle is theta radians. The entire piece would be 2 pi radians. So looking at this ratio we've set up, do a little cross multiplication. L times 2 pi equals 2 pi r times theta. I'm going to divide both sides by 2 pi, and we get the nice little formula L equals r times theta. This is only if theta is measured in radians. Right? If theta is in degrees, okay, the formula doesn't look so nice, and you can verify that one by replacing theta over 2 pi with theta over 360. Okay? Likewise, we get a nice formula for sector areas. So once again, we're going to do part to whole. We're going to set up two ratios and set them equal to each other. So we look at areas first. The area of a sector, we're going to call that A in this equation. Okay? That's the part. The whole area of a circle is pi r squared. So we know that formula from previous. Okay? The angle, once again, the part of the angle is theta. The whole angle of the circle would be 2 pi radians. Okay? And so once again, solving this with cross multiplication, I get A times 2 pi equals theta times r squared times pi. Oops, okay. Divide both sides by 2 pi, and I get the area is 1 pi cancels. I get theta r squared over 2. It's the same as 1/2 theta r squared. Okay, likewise, if we did theta in degrees, we would use theta over 360, and you would end up with a different formula. Okay. Okay. So a couple of things about these formulas. This is from the formula booklet in SL. Notice 3.1, you get both formulas. Notice 3.6, there's the sine and cosine rule in area of a triangle. So no need to memorize those. We just need to know how to use them. Okay, another thing to check out is your calculator. Make sure you know what mode you're in. Hit the mode button, which is right next to the quit. And you want to be in degrees or radians, depending on the problem. Okay, so I want to work a couple of quick examples here. So our formula for arc length, so what they're asking me to find, is L equals r theta. Okay, so see if you can set this up correctly on your own before I do it. Just a quick substitution. The radius is given as 12. Theta is the measure of the angle in radians. That's given to us as 3. So the arc length is 36, and this is in centimeters. Okay. So if you remember this formula, we were just looking at it. 1/2 theta r squared is the area of a sector. Okay. And once again, I'm just going to substitute values. Theta is the measure of the angle in radians. That happens to be 3. And r squared is 12 squared. You put that into your calculator, you should get, I think, 216 centimeters squared. Okay? Last problem. Okay? Why don't you try this one on your own, see if you can get it. Go ahead and hit pause. I want to find the area of a sector, so I use the same formula again. Okay? So substituting in, theta is the angle in radians. I don't have that, so I'm just going to leave this alone. And radius is 8.2 squared. So I need to know what theta is, the measure of the angle. Well, they've also given us the arc length, and I know that the formula for arc length is r times theta. So arc length is 13.3 equals the radius, which is 8.2 times theta. So now I can solve for theta, divide both sides by 8.2, and I get 13.3 divided by 8.2 is equal to theta. I'm not going to calculate that. I'm just going to use the value. So area equals 1/2. Theta is 13.3 over 8.2 times 8.2 squared. That's a job for our calculator. Okay? And so I think if you were to use your calculator, you should get 54.5 centimeters squared. And since this isn't necessarily an exact value, I want to use my estimation piece. So there you have it. Just one last kind of piece of information. Hopefully at this point you can solve problems similar to the examples, which is the expectation for the next time we're in class. If you need to, watch the video a second time, rewind, listen to the explanations again, try the problems again, and you want to make sure you know how to use your calculator. All right, that's it. See you guys soon in class.